March 5, 1944, 22,000 feet above Wewak, New Guinea. Colonel Neil Kirby rolled his Republic P-47 Thunderbolt into a shallow dive, the massive fighter's engine thundering as he spotted 3 Japanese Kawasaki Ki-48 bombers below. What happened next would demonstrate a revolutionary technique that had transformed the ungainly American fighter from a liability into a zero killer. But it would also cost Kirby his life, ending the career of the pilot who had proven that the heaviest fighter in the Pacific could outturn the most maneuverable. The story of how American pilots learned to make their 7-ton Thunderbolts dance with 2-ton Japanese fighters begins not with heroics, but with devastating failure. When the 348th Fighter Group arrived in New Guinea in June 1943, their Republic P-47 Thunderbolts were considered a joke. The aircraft weighed twice as much as a Japanese Zero. It climbed like a freight train and turned like a bus. Most Pacific theater commanders viewed the assignment of P-47s as punishment, a sign that someone in Washington didn't understand aerial warfare against the Japanese. The Thunderbolt had been designed for the high-altitude bomber escort missions over Europe, where its turbocharged Pratt & Whitney R2800 engine could develop over 2,000 horsepower at 25,000 feet. But most Pacific combat occurred below 15,000 feet, where the P-47 was sluggish and unresponsive. The aircraft's massive weight of nearly 8 tons when fully loaded made it hopeless in the turning fights that characterized aerial combat against Japanese pilots trained to exploit every ounce of maneuverability. Lieutenant Colonel Neil Ernest Kirby arrived in the Southwest Pacific convinced that everyone was wrong about his airplane. Born in Wichita Falls, Texas on June 5, 1911, Kirby had joined the Army Air Corps in 1937 and spent years studying the Thunderbolt's characteristics. He believed the aircraft's apparent weaknesses could be transformed into devastating strengths through proper technique and tactical innovation. The Japanese pilots they would face flew aircraft designed for completely different combat philosophies. The Mitsubishi A6M0 weighed just 4,400 pounds empty, powered by a 950 horsepower Nakajima Sakai engine. Its maximum speed of 331 miles per hour was respectable, but its real advantage lay in phenomenal maneuverability. A Zero could complete a full 360-degree turn in under 20 seconds. More importantly, it could maintain the turning performance at speeds as low as 150 miles per hour. The Nakajima Ki-43 Hayabusa, known to Americans as the Oscar, was even more maneuverable. Weighing barely 3,000 pounds empty, the Hayabusa featured unique butterfly combat flaps that could be deployed during aerial combat to further tighten its turning radius. Japanese pilots had been trained since the 1930s to force every engagement into a low-speed turning fight, where superior maneuverability would triumph over raw power or speed. American pilots arriving in the Pacific had been repeatedly warned never to engage Japanese fighters in turning combats. The standard doctrine emphasized hit-and-run attacks using superior speed and diving ability. Attack from altitude, make one firing pass, then extend away using speed advantages to escape before Japanese fighters could respond. The tactic worked when executed properly, but it required iron discipline and perfect timing. Kirby recognized that hit-and-run tactics, while effective, were inherently defensive. They allowed Japanese formations to maintain cohesion and complete their missions even if individual aircraft were shot down. More critically, they prevented American pilots from exploiting the psychological advantages that came from sustained aerial combat. Kirby believed the Thunderbolt could be flown aggressively in sustained engagements if pilots understood how to use the aircraft's unique characteristics. The breakthrough came during Kirby's intensive study of the P-47's flight characteristics. The Thunderbolt's massive weight, while detrimental to sustained turning, created enormous inertia during directional changes. When properly harnessed, this inertia could be used to maintain energy through complex maneuvers that would bleed speed from lighter aircraft. The key was learning to work with the aircraft's momentum, rather than fighting against it. Kirby discovered that the P-47's large control surfaces designed to handle the aircraft's weight at high altitude, could generate tremendous control authority when used correctly at lower altitudes. The elevator, rudder, and ailerons were all oversized compared to lighter fighters. This meant that brief, sharp control inputs could produce dramatic changes in the aircraft's flight path without the sustained deflections that created drag and bled energy. More importantly, Kirby realized that the Thunderbolt's combat flaps could be used as a tactical weapon rather than simply a landing aid. The aircraft's electrically operated flaps could be deployed and retracted rapidly during combat maneuvers. When used in short bursts, what pilots began calling the flap tap technique, they could dramatically alter the P-47's flight characteristics for crucial seconds during an engagement. The flap tap worked by momentarily increasing wing area and changing the airfoil camber. This created additional lift and allowed tighter turns for brief periods without the sustained drag penalty of full flap deployment. Equally important, the sudden change in lift characteristics created unpredictable flight paths that Japanese pilots found difficult to track. A Thunderbolt that appeared to be flying straight and level could suddenly snap into a tight turn when the pilot tapped the flaps for 2 or 3 seconds. Kirby began experimenting with the technique during training flights over Port Moresby. Using camera guns, he practiced engaging target drogues with rapid flap deployments timed to coincide with turning maneuvers. The results were encouraging. The normally ponderous Thunderbolt could achieve turn rates that approached those of much lighter aircraft, at least for short periods. The critical insight was understanding energy management during flap-assisted turns. The additional drag created by flap deployment would quickly bleed airspeed if sustained too long, but brief flap taps could tighten a turn without catastrophic speed loss, especially if the pilot used rudder and elevator inputs to maintain altitude during the maneuver. The technique required precise timing and a thorough understanding of the aircraft's energy state. Kirby also discovered that flap taps could be used defensively to avoid Japanese attacks. When a Zero or Oscar was tracking behind a Thunderbolt, a sudden flap deployment would cause the American fighter to decelerate rapidly. This forced the pursuing Japanese pilot to overshoot, often presenting the Thunderbolt with a firing opportunity as the enemy aircraft flashed past. The technique was dangerous because it left the P-47 momentarily vulnerable, but properly executed it could reverse the tactical situation instantly. The development of advanced flap tap variations required months of experimentation and refinement. Kirby identified 3 distinct applications of the technique, each suited to specific combat situations. The offensive flap tap involved deploying flaps while initiating an aggressive turn toward an enemy aircraft. This allowed the P-47 to achieve gun tracking solutions that would normally require much lighter aircraft. The defensive flap tap served as an emergency evasion maneuver when Japanese fighters achieved firing positions on American aircraft. By rapidly deploying flaps while simultaneously applying maximum power and aggressive control inputs, P-47 pilots could create unpredictable flight paths that disrupted enemy tracking solutions. The sudden change in flight characteristics often forced Japanese pilots to abort their attacks and attempt to reposition. The most sophisticated application was the combination flap tap, which integrated multiple brief flap deployments with throttle and control surface inputs to create complex maneuvering sequences. This technique allowed experienced pilots to maintain energy while executing multiple direction changes that would normally bleed airspeed catastrophically. Kirby himself could perform combination sequences lasting up to 30 seconds without losing significant altitude or speed. Training in flap tap techniques required comprehensive understanding of the P-47's power plant characteristics. The Pratt & Whitney R2800 engine produced maximum power at specific manifold pressure and RPM combinations. Pilots learned to coordinate flap deployments with power changes to maintain optimal engine performance throughout complex maneuvers. The turbocharger system, designed for high-altitude operations, could be used to provide temporary power increases during low-altitude combat. Kirby established standardized training protocols that new pilots had to master before being cleared for combat operations. The first phase involved practicing individual flap taps during straight and level flight to understand the technique's effects on aircraft handling. Pilots learned to recognize the precise control pressures required to maintain coordinated flight during rapid flap deployments and retractions. The second training phase introduced flap taps during basic aerobatic maneuvers. Pilots practiced integrating brief flap deployments into loops, rolls, and Immelman turns to understand how the technique affected energy management during aggressive maneuvering. This phase emphasized the critical importance of timing flap operations to coincide with specific points in each maneuver, where additional lift would provide maximum tactical advantage. Advanced training involved simulated combat scenarios where pilots used flap tap techniques against experienced instructors flying captured Japanese aircraft. The 348th Fighter Group had acquired several intact Zero and Oscar fighters that provided realistic opposition for training purposes. These exercises revealed that flap tap effectiveness varied significantly depending on the specific Japanese aircraft type and the experience level of the opposing pilot. The first operational test of Kirby's flap tap technique occurred on September 4, 1943, during a fighter sweep over Wewak. Kirby's flight of 4 P-47s encountered a formation of Japanese aircraft, including Mitsubishi G4M bombers, escorted by Zeros. Instead of making a single high-speed pass, Kirby ordered his flight to engage in sustained combat, using the new techniques he had developed. The engagement began conventionally with the P-47s diving from altitude to attack the bomber formation. But when Japanese escort fighters moved to intercept, Kirby demonstrated the revolutionary potential of his innovations. As a Zero turned toward his aircraft, Kirby tapped his flaps while simultaneously applying hard rudder. The Thunderbolt snapped into a tight left turn that brought its guns to bear on the surprised Japanese pilot. The Zero, caught off guard by the P-47's unexpected maneuverability, attempted to reverse its turn. But Kirby had anticipated this response. He retracted his flaps and used his aircraft's superior power-to-weight ratio to maintain position behind the Zero. A 3-second burst from 850 caliber machine guns sent the Japanese fighter spinning toward the jungle below. Kirby had achieved the impossible. He had outturned a Zero in a sustained dogfight. More importantly, Kirby's wingmen had been watching and learning. When other Japanese fighters attempted to intervene, they found themselves facing P-47s that refused to flee after making their attacks. The Americans used combinations of flap taps, power changes, and aggressive maneuvering to maintain contact with their opponents. By the end of the engagement, Kirby's flight had destroyed 3 Japanese aircraft without loss. Word of the new technique spread rapidly through the 348th Fighter Group. Kirby organized intensive training sessions where experienced pilots taught the flap tap method to newer arrivals. The training emphasized the critical importance of energy management and timing. Pilots learned to recognize the precise moments when flap deployment would provide maximum tactical advantage without leaving their aircraft vulnerable to counterattack. The psychological impact on Japanese pilots was immediate and significant. Zero and Oscar pilots who had dominated Pacific skies through superior maneuverability suddenly faced American fighters that could match their turning ability. The predictable hit-and-run attacks that Japanese pilots had learned to counter were replaced by sustained dogfights where American aircraft refused to disengage after their initial passes. Imperial Japanese Army Air Force intelligence reports from late 1943 documented the changing nature of American fighter tactics. Japanese pilots reported that P-47 formations were exhibiting unprecedented aggressiveness and maneuverability characteristics that contradicted previous intelligence assessments. The heavy American fighters were engaging in sustained turning combats that doctrine suggested should result in immediate Japanese victories. Flight leader Saburo Sakai, one of Japan's most experienced naval aviators, encountered P-47 formations employing flap tap techniques during operations over Rabaul in November 1943. His post-mission reports described American fighters that could execute tight turns and rapid direction changes previously associated only with the most maneuverable Japanese aircraft. Sakai noted that the psychological effect on younger Japanese pilots was particularly pronounced. Japanese aircraft designers began developing countermeasures to address the evolving American tactics. The Kawasaki Ki-61 Hien incorporated higher wing loading and improved high-speed handling to force combat into speed ranges where Japanese numerical advantages could compensate for reduced individual aircraft maneuverability. The design philosophy represented a fundamental shift from the traditional Japanese emphasis on extreme agility. The Nakajima Ki-84 Hayate represented the most advanced Japanese response to American tactical innovations. This fighter featured improved power-to-weight ratios and sophisticated flap systems designed to counter the advantages American pilots had gained through flap-tap techniques. The Ki-84's combat flaps could be deployed more rapidly than earlier Japanese designs, allowing experienced pilots to match the maneuvering capabilities that American P-47 pilots had developed. Japanese pilot training also evolved to address the new threat. Flight schools began emphasizing high-speed combat techniques and energy management principles that had previously been considered secondary to turning performance. Young pilots received instruction in maintaining altitude and speed during extended engagements, recognizing that American fighters could now compete in the low-speed turning fights that had historically favored Japanese aircraft. The Imperial Japanese Navy's ACE training program underwent significant modifications in early 1944. Experienced pilots like Hiroyoshi Nishizawa and Tetsuo Iwamoto developed new tactical doctrines emphasizing altitude advantage and energy conservation. These methods represented a dramatic departure from traditional Japanese fighter tactics that had prioritized aggressive close-range combat regardless of initial conditions. Combat reports from Japanese units facing the 348th Fighter Group documented specific countermeasures that proved effective against flap-tap techniques. Japanese pilots learned to recognize the telltale signs of impending flap deployment, including subtle changes in P-47 engine sound and flight path. Experienced pilots could anticipate American maneuvers and position themselves to exploit the momentary vulnerability created during flap transitions. Japanese combat reports from late 1943 began mentioning increased aggressiveness and maneuverability in American P-47 formations. Pilots who had previously dismissed the heavy American fighters as easy targets found themselves locked in extended turning battles with aircraft they had considered incapable of such performance. The confidence that came from technological superiority began to erode as Japanese pilots faced opponents who could compete on equal terms. Kirby's tactical innovations reached their pinnacle on October 11, 1943, during a mission that would earn him the Medal of Honor. Leading a flight of 4 P-47s on a reconnaissance mission over Wewak, Kirby encountered a massive Japanese formation consisting of 12 bombers escorted by 36 fighters. Despite being outnumbered 12-1, Kirby ordered an attack. The engagement that followed demonstrated the full potential of the flap-tap technique when employed by a master tactician. Kirby used rapid flap deployments to outmaneuver multiple Japanese fighters simultaneously, destroying 6 enemy aircraft in 15 minutes of sustained combat. His wingmen, applying the techniques Kirby had taught them, accounted for 3 additional victories. The Americans achieved a 9-0 victory ratio against overwhelming odds. The success was not just tactical, but strategic. Japanese commanders, faced with mounting losses to aircraft they had dismissed as inferior, began questioning their own tactical doctrines. The assumption that superior maneuverability would always triumph over speed and firepower was challenged by P-47 pilots, who had learned to match Japanese turning performance while retaining their advantages in speed, armor, and armament. By early 1944, the flap-tap technique had spread beyond the 348th Fighter Group to other P-47 units throughout the Pacific. Pilots in the 7th Air Force began experimenting with similar methods, adapting Kirby's innovations to their own tactical situations. The technique proved particularly effective against kamikaze aircraft, where sustained tracking was essential for ensuring complete destruction of suicide attackers. The method also influenced American aircraft design. Republic Aviation began developing improved flap systems for later P-47 variants, including more powerful actuators that could deploy and retract flaps even more rapidly. The P-47N model, introduced in early 1945, incorporated many of these improvements along with extended range capabilities that made it ideal for Pacific operations. Japanese aircraft designers responded by developing new fighter types intended to counter the evolved American tactics. The Kawasaki Ki-61 Hien and Nakajima Ki-84 Hayate featured improved performance at higher speeds, attempting to force combat back into speed ranges where Japanese numerical superiority in production could compensate for reduced individual aircraft advantages. But by 1944, American pilot training had evolved to fully exploit the tactical revolution Kirby had initiated. New pilots arriving in the Pacific received intensive instruction in energy management, flap utilization, and sustained combat techniques. The defensive mindset that had characterized early Pacific operations gave way to aggressive tactics that played to American strengths, while neutralizing Japanese advantages. The irony was that Kirby himself would become a victim of his own success. On March 5, 1944, during his final combat mission, Kirby encountered 3 Japanese bombers over Wewak. After destroying one bomber with his initial attack, he violated his own tactical principles by attempting a low-speed turning engagement with the escorting fighters. Despite his mastery of the flap tap technique, the P-47's fundamental weight disadvantage proved decisive at extremely low speeds. A Japanese Ki-43 pilot, taking advantage of Kirby's momentary vulnerability during a sustained turn, managed to score hits on the Thunderbolt's cockpit area. Kirby's aircraft crashed into the jungle below, ending the career of the pilot who had transformed American fighter tactics in the Pacific. His death demonstrated that even revolutionary techniques had limitations, and that tactical innovation required not just skill, but also the discipline to recognize when those techniques reached their limits. Kirby's legacy lived on in the pilots he had trained and the techniques he had developed. By war's end, P-47 Thunderbolts, equipped with improved flap systems and flown by pilots trained in sustained combat techniques, had achieved kill ratios approaching 5-to-1 against Japanese fighters. The aircraft that had arrived in the Pacific as an unwanted burden had become one of the most effective fighters in the theater. The flap tap technique represented more than just a tactical innovation. It demonstrated how skilled pilots could overcome apparent technological disadvantages through creativity, training, and willingness to challenge conventional wisdom. The method showed that aircraft limitations could often be overcome through pilot technique rather than redesigned equipment. Post-war analysis revealed the full extent of the tactical revolution Kirby had initiated. Japanese pilots interviewed after the war confirmed that American P-47 formations had become significantly more dangerous after late 1943. The predictable nature of early American attacks had been replaced by unpredictable engagements where the American fighters often held the initiative throughout the combat. United States Strategic Bombing Survey interviews with captured Japanese pilots provided detailed insights into the psychological impact of American tactical innovations. Lieutenant Colonel Yasuhiko Kuroe, a veteran Oscar pilot with 15 confirmed victories, described the profound effect that aggressive P-47 tactics had on Japanese squadron morale. Pilots who had previously felt confident engaging any American fighter began requesting transfers to units that would not face Thunderbolt formations. The technical analysis conducted by Allied intelligence officers revealed that flap-tap techniques had fundamentally altered the mathematical parameters of Pacific air combat. Traditional calculations of turn radius, sustained turn rate, and energy loss during maneuvering no longer accurately predicted combat outcomes when American pilots employed rapid flap deployment techniques. The Thunderbolt's apparent disadvantages in sustained turning had been largely negated through tactical innovation. Republic Aviation Corporation engineers conducted extensive post-war testing to quantify the aerodynamic effects of rapid flap deployment during combat maneuvers. Wind tunnel studies confirmed that brief flap extensions could increase instantaneous turn rate by up to 20%, without the sustained drag penalties associated with conventional flap usage. These findings validated the empirical observations made by combat pilots and influenced the design of subsequent fighter aircraft. The Korean War provided the first opportunity to test evolved flap-tap principles with jet aircraft. Republic F-84 Thunderjet pilots adapted Kirby's techniques for use against North Korean and Chinese fighters, discovering that the fundamental principles of energy management and rapid control surface deployment remained valid at higher speeds. The transition from propeller to jet aircraft required modifications to account for different throttle response characteristics and altered flight dynamics. American test pilot schools incorporated flap-tap training into their curricula during the 1950s, recognizing that the techniques represented valuable additions to the repertoire of advanced fighter tactics. The principles were adapted for various aircraft types, including the North American F-86 Sabre and Lockheed F-80 Shooting Star. Test pilots discovered that each aircraft type required specific modifications to timing and control inputs to achieve optimal results. The influence of Kirby's innovations extended to NATO air forces during the Cold War period. Royal Air Force pilots flying de Havilland Vampires and Gloucester Meteors received instruction in energy management techniques derived from Pacific War innovations. The principles proved applicable to jet combat, despite the significant differences in aircraft performance and operational altitudes. Soviet Air Force development programs also incorporated lessons learned from American flap-tap techniques, though this influence was not acknowledged publicly until after the Cold War ended. Captured German technical documents and debriefings of repatriated prisoners of war provided Soviet designers with detailed information about American tactical innovations. The Mikoyan Gurevich MiG-15 and subsequent Soviet fighters incorporated advanced control surface systems that enabled similar rapid maneuvering capabilities. The techniques developed by Kirby and his pilots influenced fighter design and tactics well into the jet age. The principles of energy management, rapid control surface deployment, and sustained combat engagement became standard elements of fighter pilot training worldwide. Modern fighter aircraft incorporate advanced flap and slat systems that can be deployed during combat maneuvers, directly descended from the innovations pioneered over the jungles of New Guinea. Colonel Neil Kirby scored 22 aerial victories during his combat career, making him the highest-scoring P-47 pilot in the Pacific theater. More importantly, he proved that innovative tactics could overcome technological disadvantages when applied by skilled and determined pilots. His flap-tap technique transformed the Republic P-47 from a clumsy heavyweight into a nimble fighter capable of competing with the world's most maneuverable aircraft. The story of the flap-tap technique demonstrates how individual innovation can influence the course of aerial warfare. Kirby's willingness to challenge accepted doctrine and his systematic approach to developing new techniques created tactical advantages that spread throughout American fighter units in the Pacific. His methods helped establish American air superiority that proved crucial to victory in the Pacific War. On March 5, 1944, over Wewak, New Guinea, Colonel Neil Kirby attempted one final flap-tap maneuver against Japanese fighters that had learned to counter his innovations. The technique that had made him famous could not overcome the fundamental laws of physics that governed aerial combat. But his legacy lived on in every American pilot who learned to make the heavy Thunderbolt dance with the agile fighters of the rising sun, proving that innovation and skill could triumph over apparent technological inferiority.